Hi everyone, welcome back to this channel. In this video, I'm going to show you how do we connect a Linux computer to this VNA multi-port. So as you can see, there are 4 ports out in the front of the VNA, and port 1 is connecting to an antenna just to change the S11 measurements later. And this is the rear of the instruments, so we have 12 volts input and LO800 out. We are not using that for now. And then we have the USB mini and also the USB A and the LAN connector. I'm going to put this aside and let's go through the Pi computer that we are using. So in this example, we are using this Raspberry Pi 500, which comes with a keyboard, and this is the interface for it. So we're going to connect this to a mouse, comes along this Pi 500, and this one of the USB will be used to communicate with the VNA hardware as an initial setup. Subsequently, you can just disconnect that USB to the VNA and then just use the LAN port as a means of communications. We have this power input right here, is a USB-C type, and then we have a micro HDMI. So this Raspberry Pi can be connected to 2 output. So I'm going to connect it right now and you're going to see how it looks like. So this yellow Ethernet cable is connecting to the VNA hardware, and this is a micro HDMI output to my monitor over here, and this is the SD card as a storage unit, and this is connecting to the mouse from Raspberry. So I'm going to connect the power USB-C that comes along with this card. And for the hardware side, I will connect this. So I already done the first initial setup, so you don't need to worry about the USB connectivity to make it work. So once you set up one time, and you should be fine. And then this is power. I'm going to connect the power later while I'm going through some of the software setup. As you can see here, the screen is up. I'm going to do a remote right now. So you can do a remote to this Raspberry Pi 500 using Raspberry Pi Connect, and I won't go through that today. So once you have that set up, you can do this. It's very similar to TeamViewer. It's just that this is a bit different, a bit laggy, but nevertheless, I'm trying my best to show you what it looks like on the screen so that you can have a good idea of how do we run this VNA hardware. Once it's done, so we're going to run a console. And currently the applications or the shell file is in the downloads, and this is the folder. So downloads N7021A applications. So these are the executable file that you can use to run it. So let's go back to the console. Let's change the directory to the working directory, which is under C, download, MN tab, and then application tab. So that is our working directory. So once we're in the working directions, I would suggest to turn on the VNA. So once you power it up, you start hearing the fan kicks in. So once the fan settled down, and then you start seeing this LED light inside blinking in such a way, it shows that the unit is ready for the communications and the step after this. So what we're going to do is we list now everything that's available in this working directory. So let's go to sweep. So the communication part, the IP address has been done. Don't need to worry about the communication part. So let's go to sweep. So there are a series of questions that you need to answer before moving forward, and you can actually change those setup as you wish. So these are just an example. If you need to edit, you can based on that edit it and change to some sequence that you prefer. This is written in .c, means that you have to work with the C programming. So the first question, do you want to enable message logging? I would say no. And then do you want to continue with these configurations? I would say yes. Do you need to enable interface loss communication detections? No. I won't go through every options here because it just takes a long time to explain to you what you need. In the essence of time, just want to make sure that you're able to capture some data, and from there we can work out on what are the things that you can change in the options so that it makes your data easier to work with. So before that, let me zoom in a bit more so that you can see the wording. Control Shift plus plus. So I hope you can see the wording. I'm changing it right now. Yep. So do you need to enable the unit monitoring? I would say no for now. So this is mostly factory calibrations. Do you want to construct multi-unit? Because this is just a single unit, I would just say no. Do you want to enable multi-calibrations? No. Power table? No. So just wait for a while. Yep. So this is where you're going to choose yes if you want to use the existing parameter like the start stop and the step frequency and number of sweep count, and then I have bandwidth. But if you want to change any of this parameter, you click no. Let's start with no. Please choose a sweep state, normal sweep, segmented. I'm not sure whether it's ready, but we are not using it for now. And start frequency, let's say we want to start with, because the start frequency for this VNA is 8 GHz. So the start frequency I think is 10 MHz. So you can type in this way, 10E6 or 10 with 6 zeros at the back. And start frequency we can stop at 8 gig. So let's try 1, 2, 3, 4, 5, 6, 7, 8, 9. So click enter. Frequency step, this is where you want to determine how many points you want to run. So let's start with 10 MHz per step. Number of steps within the block, this is where you want to get average of the reading. So let's say we want to have a 5 reading, and then IF bandwidth. If I want to have a 25 kHz IF bandwidth, instead of typing 25, I have to type 8 over here. I would recommend to save that to CSV file, which is number 2. Map memory is for you to use it for subsequent script. So for now, we go with number 2. Do you want to proceed and perform sweep? Yes. So it says start frequency error file, means that it can be 10 MHz. So let's try again. Sweep. Message logging, no. Configure, yes, because these are the LO stuff. And then Ethernet detection, no. No, 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 no. So we want to change this. Let's start with 100 meg. 100 meg, 100E6, 8E9, 10E6. Let's start with 4 and then 8. 2, yes. Code system initializations. This warning will come out when you start the machine code. The optimum working temperature is about 55 degrees. You can choose no for now, doesn't really matter. So you check the internal temperature just to make sure that reference clock is good. You can choose no, but I do recommend to warm up the instruments at least half an hour, power on, and then only start measuring. So this is the one that you have to be aware of. If you put yes right now, you average the block data, and then it will come up with one single result after the 4 measurements up here. So we ask for number of sweep, 4 measurements. If you click here yes, the result will be a combination of average of the 4 reading. But if you click no right now, you will see 4 different data which capture in one go. So then you have to do your own averaging. So it's up to you. I will show you the difference later. Put yes for now. Do you want to specific? So normally I don't change any of the default naming conventions. So you want to change, you click yes. No, I don't really want to calculate the time. I don't really want to monitor. This way you're going to set yes if you want to repeat the measurement at the same condition. So let's say we do it one more time. So you're going to see 2 results over here. So the result is under application data, and this is the result that we just did just now. And we can open it because there's a LibreOffice installed in this Pi machine. So the reading that you're getting here is linear, it's not logometric. You have to translate that to log using 10 log base 10 watt over 1 milliwatt. So this is the whole string of data here, and you can plot it out if you want. And we can do this, insert chart. So you can see that the best working point is over here. So this is how it looks like, but this in linear format. You might want to change that to log. Let's go back here. So this S11 measurement, this magnitude, this phase, S21 magnitude, S21 phase. So you have the whole combinations of 16 parameters there, and yeah, go crazy with it. And I'm going to show you another one here. If in the event where you have this, when you set the combined average combine into one reading and then you say no, this is the result I'm going to see. So let's say I set 5 reading. So this is the first one, this is the second one, this is the third one, fourth, fifth. So it's separate into multiple measurements at one go, and you have to do the averaging yourself. So there are pros and cons. Some people want it that way, some people want to remove the outliers to get the data nicer, so it's up to you. In more detail, contact your local Keysight support. They should be able to guide you through in some of the things that you want to do. So it's a bit long. Hope this helped. Thanks for watching.